If you need to load 100 plus or 500 plus table data as is to the Snowflake Cloud Data Warehouse, you will need to use a paid tool or cloud native services, which will cost you money. And if you have to repeat this process for any reason, these paid tools or cloud native services will charge you for each repetition. You can also use SnowSQL CLI put command and repeat this, but you will need a lot of manpower or time to do it manually. If you like such approach, probably this video is not for you. But guess what? If you can write a few lines of Java or Python code, you can not only replicate the dataset from sources like RDBMS system into Snowflake, but you can also generate table DDLs at no extra cost. Do you think this sounds exciting? To accomplish this small but significant goal, you must use one of the programming interfaces known as JDBC or Java Database Connectivity. Snowflake implements this programming interface itself, allowing Snowflake developer to interact with your Snowflake instance. So, in this video, you will learn about Snowflake JDBC Driver and many simple and easy tricks that will increase your day-to-day productivity while building solutions. You will be able to answer following questions confidently once you finish this episode. Does Snowflake support JDBC Type 4 driver? Does Snowflake JDBC driver require Java 1.8 or higher? What are the prerequisites to run a Snowflake JDBC driver program? How to download and configure JDBC driver to interact with Snowflake? How JDBC driver works if my Snowflake authentication happens via SSO or identity provider? Can this JDBC driver support Maven based Java project? If so, how the POM dependency looks like? Can JDBC driver be used when multi-factor authentication is enabled for my Snowflake instance? So if you want to know how to interact with Snowflake using Java JDBC API and become more proficient and efficient in developing data solutions, stick with me until the end of this video. Welcome back to my channel Data Engineering Simplified and to this real jumpstart course for Snowflake data professionals. The last 23 episodes in this series already covered history to architecture, data loading, micropartitions, time travel, cloning, stream, task, role and role hierarchy, stored procedures, functions, views, information schema, resource monitor, and many more important concepts. The part 1 of this episode 24 will deep dive into Snowflake JDBC API and its programming construct that will help you to build a working knowledge. We will explore where to find the Snowflake JDBC driver, configure parameters to connect to Snowflake instance, how to use Java API to interact with Snowflake, and execute different DDL and DML operations. We will practice everything using Snowflake free trial edition and have hands-on exercise to cover all the concepts listed in this slide. So let's begin. Before we move next, let me ask this. Do you want to have mastery in the Snowflake Cloud Data Warehouse? I believe you should be because there are many amazing opportunities available if you are familiar with the Snowflake Cloud Data Warehouse system. I have been adding a lot of great content to help the Snowflake community. The response I received from my audience much exceeded my expectation. People are getting certified on their first attempt and scoring nearly 100%. My free content is used by data engineers, data lead, architect, and even data managers. You don't need to buy any expensive courses. Check my playlist. It includes almost everything to make you a successful Snowflake data professional. So, if you find something useful in this content, please press the like button. Leave your opinion in the comment section or send me a direct message on Instagram. Before we begin and understand the JDBC driver and its programming approach, let's try it out using a free tool called DBeaver, also known as Universal Database Manager. The community edition of DBeaver is free and all the major features work in this edition. And you can also have Git plugin installed to have your SQL script version in tools like GitLab, GitHub, or Bitbucket. I have already downloaded the DBeaver, and now I will show you how to configure Snowflake instance and what role JDBC Driver plays here. We are using this tool to make sure the authentication and the configuration setups are working before we can go and use Snowflake JDBC Driver for your Snowflake instance. This is my DBeaver 22.1.5 version. So first, I will click on this icon, which will help me to establish a new database connection. And these are the popular databases which is supported by the DBeaver. Now I am going to search Snowflake. And here the Snowflake is available. When DBeaver try to interact with Snowflake, it needs a Snowflake JDBC driver. If the JDBC driver is not installed in your DBeaver, it will try to download the JDBC driver from Snowflake website. I have selected that. Click on the next button. And here I am presented with this screen. First, it will ask for the host name. So the host name start with account number. In my case, it is VQ16340, followed by the cloud region. Here it is AP Southeast 2, followed by snowflakecomputing.com. According to your Snowflake instance, you can choose a database name. In my case, it is a testdb. I am going to use a compute virtual warehouse. The schema which I want to connect by default with this connection is a test schema. Now I am giving the user ID and password. You can also check and uncheck this save password locally. Now I am going to give the role. You can change the role as per your Snowflake role. Here, authenticator, I am leaving it blank. By default, it will go for a username and password. If there are other options like key pair, external browser authentications, and many more options are there. Now, once my hostname, database, warehouse, schema, and everything is given, I will click on this button called test connection. Let DBeaver perform the test connection using the JDBC driver. So it says that password invalid. Okay, let me correct the password. I think I made a mistake. Here I can see my JDBC URL. Connection got successfully, and it says that I am using Snowflake driver 3.12.12, and the Snowflake server returns the Snowflake release 6.29.0. Okay, it means all the parameter what I have specified here is working fine, and with this information I can really download a JDBC driver and use this parameter to connect to my database. Now let's go back to the Snowflake web UI and see how this connection looks like in my query history tab. When I come to my history tab, I can see the JDBC connection has been established. And here the client information says I executed these queries through JDBC 3.12.12 driver. And here I can also see all the informations including OpenJDK runtime environment. Now coming back to this screen, I will say finish. And now, so this is my database navigator. I click on this icon. Let's see this test database. I have test schema. I can see all the tables and employee. Right click on here and say view table. This is how the table looks like. I can see the table data. I have only one record, and I can also have the ER diagram. This is how you can use DBeaver and first understand whether you are able to connect to your Snowflake instance through the JDBC driver or not. If this works, there is a good chance your Java program will not fail for any configuration reason. Okay. If anything goes wrong, you can always come and check here what kind of queries are being executed and whether it is coming from the JDBC driver or through any other client. We are not going to talk through what is JDBC driver, as there are a lot of good resources available in the internet. But we will quickly look how this type 1 to type 4 drivers look like and how do they interact with the databases. If you see this diagram, type 1 to type 3 drivers need many layers before it reaches to the database. On the other hand, type 4 drivers does not need any middle layer or so-called middleware servers, and it is purely developed in Java, and that's why it is platform independent and also called thin driver. Since it is a platform independent, be it Windows server or a Linux server or any personal computer, it works seamlessly as long as you have Java runtime environment or GRE installed in your machine. And that's the reason most of the databases like Snowflake provides type 4 JDBC driver. Let's see where to download this driver from. We as a developer have a habit of searching in Google and download whatever comes first. However, my suggestion is to download it from Snowflake web user interface. So whatever be your role in your Snowflake environment, you can go to the Help tab and click on the Download submenu. Select JDBC Driver and click on the Maven repository hyperlink. This opens up the Snowflake JDBC Maven repository where all the version of JDBC drivers are available. Scroll down and find the latest version of the driver. In our case, it is 3.13.22. Validate the release date. Here, the release date is August 23rd, 2022. Click on the file which has a file extension .jar. The jar stands for Java Archive or Java Archival. In simple terms, it is a binary or executable for your Java program. The legacy web UI allows you to download JDBC driver. However, Snowsite has not yet got any link which can direct us to the Maven repository location. Maybe in future it will be added. However, as on today, it is not available. Now our jar is downloaded and we will see how to use it once we understand our Java JDBC program. Let's quickly understand this simple Java code which establishes a connection to Snowflake data warehouse and fetch the result and print them. Here is our Java JDBC program. I assume you have basic knowledge of Java programming language and its construct. Here, line number 1 is a package definition for our Java class. Line number 3 to line number 9 are importing Java SQL and Java util libraries, which we are going to use it. These libraries will be used to set the configuration parameter and establish connection via Snowflake JDBC driver. Line number 11 is the name of the Java class followed by the main method, which is the entry point for this Java program. Line number 16 creates a java.util.property object named properties. We create an empty object and this will hold all the key value pair. Line number 17 to 23, we are using put method to set the key value pair in the properties object, where we are passing username, password, warehouse name, database name, schema, and role name. Now our property object is all set and Snowflake specific configurations are fed into this property object. Next, we are creating a string variable called JDBC URL and assigning the JDBC URL string. If you notice, it has 3 parts. The first part is a standard JDBC string, which is also known as the communication protocol. The second part is the name of the database, and in our case, it is Snowflake. If you connect to MySQL, this text will be replaced with the word MySQL. Third part is the host name where this database server is residing, and in this case, it is your Snowflake account number followed by your cloud region followed by snowflakecomputing.com. If you do not know what is your account number and what is your cloud region, you can go to the legacy web URL and the legacy web URL will have all the details available. You just have to copy paste and replace this text with that URL. Now we are going to construct another string called query and assigning a select statement. You can have any kind of statement in this query string. So far, we have only defined different variables and assigned values. Hope these all look simple and straightforward. Moving to the next set of lines. Line number 32 creates a connection object using Driver Manager API. When we call getConnection method, we provide 2 inputs. The first one is JDBC URL, which has a Snowflake host name, and the next input is the properties, which has user ID, password, and additional details. If we have provided any incorrect input parameters through this input variable, line number 32 will raise an error and it will fail to establish a connection with the Snowflake. If this line passes through, means our connection is established with a Snowflake. Line number 33 is creating a statement object. And finally, line number 34 is executing the select query and getting the result set. Now once we get the result set, we can iterate through each row and extract individual column or apply any other logic and print the result. So that's simple our Java JDBC Snowflake program looks like. Now let's run this simple program and see whether it works or not and how to include the jar to make this program run successfully. So here I am in my IntelliJ IDE. You can use any editor to write your Java program. So the line number 1 is nothing but package declaration. Line number 4 and 5 is primarily using the import statement to import all the Java libraries like Java SQL and Java util properties. Line number 9, we are declaring the Snowflake JDBC as a public class. Line number 12, we are primarily defining a main method which is also an entry point for this Java class. From line number 15 to line number 22, we can see I have defined this properties object. We are creating an instance of property object and we are setting different values which are required to establish a Snowflake connection. On the line number 25, we have this URL where it starts with JDBC as a protocol, Snowflake as a JDBC driver, followed by host name for your Snowflake instance. Line number 28 is a select statement, and this statement will be executed to check whether we can communicate with a Snowflake instance or not. Here on the line number 33, we are establishing a connection by passing this JDBC URL and the properties. And once we establish the connection, on this connection, we create a statement object, and this is how it looks like. It returns a java.sql.statement object. On this statement object, we call a method called execute query, and this takes an input parameter which is here select start from employee table. If this query is executed successfully, we will get the result set, and we can iterate through the result set and we can extract the different column from this one. Let's go back to our Snowflake instance and validate what is the data set we have in this employee table. I can see I have only one record available in this table, and when we try to execute the same command through our JDBC connection, I should be able to extract this result. Okay. So before we go and run this Snowflake JDBC Java program, we have to make sure that our JDBC library is available. Right now I am using JDK 1.8, and let's see how many different libraries we have it. So we have seen how to download the Snowflake JDBC 3.13.22 jar. I have already imported that jar. Okay, if this jar is not available in this location, it will end up with an error. Let's see how to import this jar. Different IDEs like Eclipse, IntelliJ, Atom, and VS Code, each of them are having a different mechanism to include the jar. In IntelliJ, we go to the file menu, click on the project structure, and from the project structure, we go to these libraries, click on this plus button, and we add the jar and click on OK. And that is how this jar is included into your class path. If you are not comfortable using any IDE like Eclipse or IntelliJ and having challenges adding jar into the class path, you can also go to the command prompt. You can simply run javac. When you run the javac, you will get an option called class path -- class path. So what you can do, you can have javac -- class path, the location of your jar file, and you can compile your Java program and generate a class file. Please drop me a note in the comment section and send me a direct message to my Instagram account if you find any difficulties connecting to Snowflake because of this jar file. So I'm going to click on this green icon, which will help me to run on a debug mode. So let me run this Snowflake JDBC main method. You can see here it is starting to connect to the Java program. Now my program got executed successfully. This is my connection object ID, followed by my statement object, and followed by my result set object. And I can see the employee ID, age, first and last name are also displayed. And this is how my Java JDBC program executed successfully. Now let's go back to the Snowflake query history and see how does it look like. So my query text shows that it got executed, and it is connected through JDBC 3.13.22. So this program looks like. Okay. Next, we would try to see how to create a table and understand whether we need to make any changes to our existing program. Our connection property looks exactly same. There is no change. Our JDBC URL also looks same. No changes. We are creating a query which represent create or a replace table SQL statement. It is creating a table called JDBC demo 01. And it has only two fields, ID and name. On line number 33, we are establishing a connection. It is exactly the same, no change, followed by we are creating a statement from this connection object. Once we got this statement object, we cannot call execute method for insert, update, delete or DDL statements. For that, statement has another method called execute update. And if you see the documentation, it says execute SQL statement, which is an insert, update, delete statement or an SQL statement that returns nothing, such as DDL statement. Now, this is my DDL SQL statement. By calling this execute update method, I am going to create a table in a Snowflake environment. So let me run this and see how the result looks like. Again, clicking on this green icon, and I saw my name changed. Here my program got executed successfully, and to validate that, I will switch to my Snowflake web UI. I can see my table created successfully. Let's go and validate through the database tab. So here I am in my test database under my database tab, and when I go to the tables tab, I can see my JDBC underscore demo01 is created successfully. And this is how I can use a Java JDBC program to create a table or any kind of object in Snowflake. What if I have to not only create a table but also insert handful of record to that particular table which I created through the JDBC? So how can I write a program for that? So this is my another program called Snowflake JDBC DDL DML. So through the DDL we will create the table, and through the DML operation we are going to insert handful of record. I am setting the properties is the same as a previous program. JDBC URL is also same. I am creating a table called JDBC underscore demo02. This we have seen in our earlier program. These statements are exactly same. I am executing that SQL query which is creating the table. And the next, I have set a variable called record insert. 10 is a value assigned to this variable. I am running a loop, and in this loop, I am running a statement insert into JDBC demo02. And values are my I as a counter and name concatenated with I. And I am going to see how does it print. And finally, I am calling execute update statement because this is a DML operation and not a select statement. And finally, I am also printing how many records got inserted. This is also a simple program. I have extended the previous program by adding few line of Java code. So let's run this. Again, clicking on this green icon. So I can see 10 records got inserted because it starts with value 0 and end at 9. Let's go back and validate how does it look like on our web UI. So here I can see each of the insert statement is executed as a single command, and all of them got executed through the JDBC 3.13.22 driver. Okay, looks good. It has used a warehouse because insert statement needs a virtual warehouse. Let's go back and check the database. Here I can see JDBC underscore demo02 is created and it has got 10 record. So this simple is to interact with your Snowflake instance, and you can do all kind of possible operations. This is how we can interact with our Snowflake instance using Java JDBC Connect. Now let's understand how the Maven dependency looks like if you want to build a Maven based Java project. So this is the same example we are talking about, and let me open my pom.xml. So this is how my pom.xml looks like. From line number 17 to line number 21 is the Snowflake JDBC dependency, and the version says 3.13.20. And let's see how does it look like when we build through the Maven project. So my build is successful, and this is how you can incorporate Snowflake JDBC through a Maven dependency. The Snowflake JDBC driver runs on Java 1.8 and above. So if you are having any version equal to 1.8 or greater than 1.8 with the Snowflake JDBC driver. Let's say your organization uses single sign-on or identity provider based authentication. In that case, you generally do not get an option to use user ID and password, and your identity is validated against your Active Directory user ID. If that is your requirement, in that case, you won't be able to connect with Snowflake using your user ID and password. In such case, Snowflake provide another option called authenticator as a parameter, and the default value is Snowflake, which enables to access Snowflake instance through the user ID and password. However, if you have single sign-on enable or Active Directory based authentication, in that case, you can specify authenticator equals to external browser. Okay, and once we specify this parameter, you don't need to have a password because your authentication will happen through the browser-based authentication. Okay, so let me run this program and let's see how does it open the browser. So my program started running. I got this user ID popped up in the browser. Here I can click and authenticate myself. Once this authentication is done, it will allow the program to run. Right now I'm not going ahead with this authentication. I just wanted to show how this authentication works. Okay, if you want to do passwordless authentication or private key based authentication, then there are other authentication parameters available which will help you to register your private key, and then you can establish a connection with Snowflake and proceed. Let me show you how to move your data from your RDBMS system to Snowflake using a simple Java JDBC program. Before we jump and run the program, let's understand the building blocks. The program which I am going to show needs a lot more improvement, and I am demonstrating a very basic version of the program that has many hard-coded values and needs further enhancement. The optimized version of this Java code will be available as binaries in my Git repo, and feel free to download and run it by passing different configuration as per your need. The binaries will be available for PostgreSQL, MySQL, Oracle, and SQL Server, and they will help you to move your data at no time from your local or RDBMS database to Snowflake without any cost or any expensive cloud native solutions. So let's visualize what we are going to do. Let's say we have three tables in our PostgreSQL database named customer, line item, and nation. For simplicity, we just have two columns in each of these tables and 10 records per table. We need to move this data to our database called data warehouse _ dev as well as data warehouse _ QA database under stage schema. Before that, we would like to create tables for each of them and then push the data to the respective tables. Let's quickly see how this table looks like using our DBeaver tool. So here I am in my DBeaver tool. The way we established a connection with our Snowflake database, you can also go create a database connection and select a Postgres and connect your Postgres or a SQL Server or your MySQL database. I have three tables called customer, line item, and nation. Let's see how the customer, line item, and nation looks like. So I can see I have only two columns called first name and last name in the customer table, and I have total 10 records. This is my another table which has a line item name and the description. Again, I have a 10 record. And this is my third table called nation, which has a nation name and the nation code. These are all dummy data and the dummy table for our demonstration purpose. Let's go back to our slides. To move our data from Postgres database to Snowflake, here we have total 6 steps in our process. And these steps will help us to move our data from Postgres database to Snowflake data warehouse system without any manual effort. Step 0 will establish a connection with Postgres database using Postgres JDBC Driver, very similar to what we have done for Snowflake. Step 1 will fetch all the table names using Postgres information schema and keep that table list into Java's array list object into memory. Step 2 will fetch all the column list using step 1 table names and create Snowflake compatible DDL statements. Step 3 will use step 1 table list output and create insert statements which are again compatible with java.sql.prepared statement construct, so we can run the insert statement in batch mode. Step 4 will use step 1 table list output and fetch all the table data and store them in a list form into Java's runtime memory. So step 0 to step 4 will interact with Postgres SQL database and build all necessary SQL script and hold them into Java's runtime memory. If you want, you can also store these SQL script as well as data into the local disk and you can call them one by one. Step 5 will establish a connection to Snowflake database and run those DDL statement which is created at step 2. Once step 5 is successfully executed, step 6 will trigger and use the step 1, step 3 and step 4 output and load the data to Snowflake data warehouse. You can pause the video and look into this step and try to understand and visualize how these overall steps and building blocks are designed. In this example, we are not taking care of many important programming aspects like exception handling, etc. However, My binaries, which I am going to make it available in my Git repository, will have most of them, and I will continue to enhance this program to support the community based on your feedback and your valuable suggestion. So feel free to download the binaries, try in your environment, and give me the feedback if you need any additional enhancement. For each of the step, there is a corresponding method in Java, and this is how they look like. Step 0 is a connection method to a database, and we are starting from a meaningful step called step 1 to step 6. Let's try to understand this step 2 method mapping. Step 1 will try to fetch all the table names by calling a method called getTableNames. Step 2 will consider the output given by the step 1. It will pass that table names and then construct all the DDLs which are compatible to the Snowflake. Step 3 is primarily designed to construct the prepared statement, and it will call a method called createPreparedStatement for Snowflake. If you do not know what is prepared statement in Java, I would request you to go and do some research. Now we will move to the step 4. Step 4 is primarily generate the insert statement by fetching all the data from the Postgres database. So from step 1 to step 4, all those operations will be performed on your Postgres source database. Step 5 will use the output from step 2 and try to create a database using this method called createTable in Snowflake. Once our tables are created into the Snowflake, then we will insert the data using this different output given by step 2, step 3 and step 4. I know if you are not familiar with the Java coding, it will be a little hard for you to understand. However, I will make this entire coding available in my website. Let's go a little deep and understand how each of these methods are working. Let's understand our step 0. If you look into the line number 45, you will see the difference from our previous program. It starts with the JDBC, which is the same protocol for Java, followed by Postgres SQL. Make sure that you do not make a mistake here and give the proper word called Postgres SQL. In our earlier example, we have seen this value was replaced with Snowflake, followed by localhost or the host name of your database and the port number and the database name. So this program is not doing anything. It is just establishing a connection with your Postgres database and returning the connection. Moving to the step 1, and let's see how this method looks like. So step 1 will fetch all the table names from the Postgres database. It just needs a database connection. So you can see line number 60 is getting a database connection, and then line number 66 is primarily executing a query on information schema tables table. And from there, line number 71 is actually executing this query and extracting the information through the while loop from line number 72 to line number 75 and adding all those values into a list, and line number 85 returns the list. So now step 2 will build all the DDL statement using this table list. So this method is called createDDL for Snowflake. It takes a connection object and the list which we have prepared in the first step. So line number 99 to 82 dynamically constructing a query which is using information schema.columns table, and once this query is constructed, this query is being executed at line number 105 and finally extracting the column name and column type. In line number 115, it is also adding that DDL into a list and finally returning the list to the caller. So step 3 will create a prepared statement for Snowflake. We can also prepare a normal statement. However, normal statement will be slightly expensive and we want to optimize our operation here. So if you look into the line number 138, it is actually creating an insert into statement, and line number 139 is having a value, and finally we are concatenating all those extract at line number 154 and 155 and finally building insert into values followed by question marks as a prepared statement. When we run the program, you would be able to visualize how this piece of logic works. Now, step 4 is primarily fetching all the data from Postgres and storing them into memory. This is how the Java method looks like. It is taking a connection object and all the table names. At the line number 180, it is simply constructing an SQL called select star from the table. it is executing the query at line number 183. Once the query is executed, line number 187 and 188 is extracting the column values. For now, it is hard coded, but my future program will make it more dynamic. So line number 189 is adding those row data into a list. So this is how this program looks at high level. You can pause the video and try to understand how the overall construct is designed. So if you look into the return type, it is a map type which will have all the table name, and for each of the table name as a key, it will have a value, and that value is nothing but a list of all the rows which are available in our database. So we have completed from step 1 to step 4, where we have interacted with Postgres database. Now step 5 will create the table and then insert the data through the step 6. So the method name says create table in Snowflake. Line number 241 will create a for loop, and for each of the table, the DDL statement will be created through the line number 243. And this is a very simple method. Okay. Once our table creation is done, we will close the statement as well as we'll close the connection. Moving to our last step, step 6, where we will primarily load the data. This method may look little complex, but stay with me and I will try to explain. This method will also take the target database connection, the name of the table, and also the prepared statement. Okay. So if you look into that, line number 262 will set the auto commit equals to false, and this is one of the important things. Whenever you are doing a bulk operation, have the set auto commit equals to false. And if you have been writing stored procedures or any other database object, you might be aware of auto commit parameter. Now it iterates through each of the prepared statement, and in the line number 269 it creates an object called prepared statement. Once this prepared statement is created, if you look into the line number 280, it iterates through each of the object which is stored in our list, fetch the element 0 and element 1. Right now this is also hard coded, and finally add that prepared statement to the batch, and which is there in the line number 218. Once we batch all of them, we execute the prepared statement through the execute batch, and once it is executed, all the data which are part of the batch will be inserted into Snowflake database. So let's go to our IntelliJ IDE and let's see how the overall program really works. So this is our Java program called ingest RDBMS to Snowflake. You can see that my IDE is using JDK 1.8 and it has Snowflake JDBC 3.13.22 jar as a target database JDBC driver, and I am using Postgres 42.2.5 jar as a source JDBC driver. So we have step 1 to step 6. We have already discussed these methods and the flow of the methods. This is the connection for our Snowflake. Here it is connecting to a database called data warehouse underscore dev. It will try to create the tables into stage schema. Let's quickly review how the stage schema looks like. So I have two databases. I would like to load all the tables and the data in each of these databases without making any changes except the database configuration change. Okay, let's go and review whether there is any table available inside this database or not. So there is no table and there is a schema called stage schema. Good. Underscore QA database also does not have any table and it has a schema with the same name called stage schema. Now I can see line number 39 is actually fetching a connection from our source database, and this is how it looks like. Here I have a Postgres. I am connecting to the local host and this is my port number, my database. We have already seen how to establish a connection with a Snowflake. Let's quickly review it. This method is passing the parameters, establishing a connection and returning the connection object. Now it is time to run this Java program. Okay, so I'm clicking on this green icon. Now my program started running. All the system.out is printing the necessary information on the screen and my program is completed. Let's go and first validate tables are created and data is available in Snowflake or not. So I can see there are 3 tables which are created and each of them has got 10 records. Looks good. Let's see how easily we can replicate this process to a new database called QA. So I am saving a program and trying to run the program once again. So my program is running. Step 4, step 5, step 6, and yeah, it's almost done. Okay, let's go and quickly review. I can see my tables are available and it has got exactly 10 records. So this is so easy to replicate your data from environment to environment and repeat the process again and again. Okay, let's understand what's happening here. This method is executing this particular statement, getting all the tables, wrapping them into a list. And this is the line which is being printed here. You can see system.out.print and all the tables names are printed. Okay. Moving to the next method is creating a DDL. You can see here create or replace table, line item, name and text. Okay. Here it is running a query into the information schema columns table. Okay, and the table is being injected dynamically. Once this SQL is created dynamically, it is being executed in the line number 103, and finally it is wrapping those create statement through this string concatenation. Okay, good. So this is all 3 lines. I got all the table names and all the DDL for respective tables. Now moving to the step 3, it is trying to create the prepared statement, and when I say prepared statement, you will see we are preparing the statement without having actual values. And here if you see, insert into line item, name, description, and they have a respective questions marks here. Let's see the method. So this is your prepared statement. It is creating insert into followed by values, and it is performing the same thing. It is, instead of getting the column name and the type, it is actually replacing them with a question mark. Okay, so this is how this method runs. Next is getting data from the Postgres. This is slightly complex in terms of object structure, but don't worry, if you run it by yourself, you would be able to follow that. So here in the line number 178, it is running a statement select star from a table name. We have hard coded 2 columns. It is getting the data and wrapping the data into a list. And then once that list is created, that list is finally tagged against the table name into a map. And finally, this data size is being printed along with the table name. And this is how you will get this print statements. Now the 5th statement is a very simple one where we are going to execute DDL statement and get the table created. So here I am calling this method create table in Snowflake. You are calling your DDL statement through execute update and your table is created. That simple. Last method is called insert data in Snowflake. It is taking the target connection, table name, prepared statement, and all the data sets. So it is taking 4 input parameters and it is iterating through the prepared statement. And here we are creating a prepared statement. And through the set string, I am passing the data value and finally calling this add batch. And on the line number 284, I am executing this batch. Once this batch is executed successfully, I am calling this commit method to commit all the insert statement. So this is how this program is running, and you can download this program from my website and you can also try running in your environment. And if you have any specific feedback or challenges running this program, you can drop me a direct message in my Instagram account. Okay. Let's quickly see how the history page looks like. So here I can see commit is being recorded separately. All the inserts are happening through the prepared statement. So we executed 30 insert statement. However, we can only see 3 insert statement. Okay, so it has already optimized your execution, and I can see all the execution has happened through the JDBC driver, and the total 10 rows for each of the table got executed successfully. Now you know how easy it is to work with Java JDBC driver and make lot more productivity tools using Java programming language. Many enterprise development teams spend thousands of dollars to move their data from on-premises to Snowflake cloud and spend many weeks to achieve this. And with this simple Java program, you can move if not terabyte of data, but GBs of data easily from on-prem to Snowflake cloud without even a single penny. Okay, so you may ask a question, is it possible to achieve the same or a similar things using ODBC driver? And does it have any limitation or advantage over JDBC driver? There are many reporting and BI tools which runs on ODBC driver, and it is equally popular. And our next part of this episode 24 will explore the ODBC driver. So don't forget to watch the next chapter. It will help you to decode many hidden possibilities with ODBC driver. I hope you have been enjoying this Snowflake learning series. And if there is anything good in this video, please press the like button and leave a comment. If you have any other suggestion, feedback or important note, please drop me a direct message to my Instagram account. Thank you and happy learning.